Good morning, and thanks for joining today's broadcast, Inline Analytics with Redis Fraud Mitigation. Today we have two presenters, Lena Josie, Vice President of Product Marketing, and Kyle Davis, Technical Product Marketing Manager, both from Redis Labs. Redis incorporates a ton of cool data structures that make analytics simple and high performance. Today, Lena and Kyle will explain how to use Redis for real-time analytics as fraud detection, recommendations generation, maintaining distributed counts for metering, estimating elements frequency, and reporting. They will highlight how data structures in Redis can be used to implement specific fraud detection checks in your application with live demos. Today's broadcast is being recorded and all attendees are in listen-only mode. During the broadcast, we will be taking questions, and you can post your questions using the question and answer module in the communications panel. Your questions will be answered in the order that they are received. Following today's broadcast, an email with a link to the recording will be sent to you for future viewing and to share with your workmates. At this time, I'll turn the broadcast over to Lena. Hey, Lena, take it away.
Thanks, Sharon. Hi, everyone. Welcome to this webinar. I'm Lena Joshi, and I'm going to be doing a quick introduction and setup of what Kyle is going to talk about. So today's agenda, we'll talk about why use analytic capabilities in Redis, what types of use cases Redis is useful for in the analytics space, what are the options available for you within Redis data structures and modules that you can use for analytics scenarios. And then Kyle will jump into specific examples around fraud mitigation and walk you through three specific scenarios on how you might implement the analytic capabilities of Redis. So let me get started and talk about first what types of analytics I'm talking about. So before we jump into the analytics that you can do with Redis, it is important to highlight that when we talk analytics, we're not talking about the business intelligence scenarios where you have data in some cold data storage and you're pulling reports at the end of the month and you're doing what-if analysis. This is much more real-time than that. This is data that you need processed quickly, decisions that you need to make right away based on that data, for which you need to do computations in real time. And the main reason for this is Redis sits in memory. It is blazing fast, and it can compute these things in real time that can allow for very automated decision-making scenarios. So what are some of these scenarios? So an example can be that you're walking around neighborhood and your phone is on, and these days, of course, everyone's looking at their phone while you're walking around. And your app wants to present some ads to the user based on his or her real-time location. Depending on where the customer, where a person is using your app from, or what sites he's browsing, you want to make personalized offers based on his or her most recent activity. Third scenario is someone is using your website and your application. They may be on a mobile device, or they may be on a desktop or a laptop, and they're browsing, and based on their browsing history, you want to make recommendations for them in real time for articles to read or for next steps that they can take. Other examples are, we've all heard of the Internet of Things. We know that there are many millions of connected devices all around the world. The data from these connected devices is received at what is called as edge locations, and it's useful when you can make decisions like switch on or off a device, or call for maintenance of a particular device, or take some corrective action scenarios, or power real-time displays with the data coming from these scenarios and from these devices. And in these types of things, the data is available in real time, and it makes no sense for us to store the data for a while, then think about what we want to show, and then show it. Rather, you want to see what the devices are displaying or are telling you in real time, process that data right away, and make it available for people to look at. So these types of examples require many types of data coming in at you in real time, being processed in real time. The other examples, and these are the more common examples that we see with Redis already, is leaderboards, game counts or game scores, ratings of most liked or most read articles. These things are already generated out of Redis. And as an example, if you use Twitter and you've ever used the Twitter analytics, the analytics feed entirely comes out of Redis. All of Twitter actually comes out of Redis, but analytics feed in particular displays that you can use it for real-time analytics. Now, what in Redis enables these analytics? So first of all, you have a number of data structures. Some of them you may be familiar with, some not. You may already have heard of geospatial indices inside of Redis. You may already have heard of sets. You can use the geospatial indices for location-based searches. Set cardinality can be used for fraud mitigation. But in analytic scenarios, we find that data structures such as hyperlog, sorted sets, and bitmaps play a big role because things like hyperlog can count unique items without spending a proportional amount of memory on those items. They're probabilistic estimates with a very, very small standard error of 0.81%. So if you want to maintain counts of many, many different items and you want to know when your count is out of bounds for anomaly detection or things like that, hyperlog is typically a data structure that you can use for this. You can also use sorted sets where you store items along with the associated scores. You can do real-time range analyses. You can compute top scorers and bid ranges with the built-in commands in Redis. With bitmaps, a bit is set in memory for every item you want to count. So as an example, if you're a large website and you have lots and lots of users, and you want to set a bit for every user, then you would use something like bitmaps to actually set a bit for every user, and then bit count to display how many users are online at the moment. And you can use these bitmaps. Again, this is a very memory efficient way to implement counts for things like activity monitoring. In addition to the built-in data structures, you also have several modules that are available with Redis that can implement many types of inline analytics. So as an example, Redis ML, our most famous module, does machine learning model serving. So after you finish computing the machine learning models and you want to serve these in real time, you would use the Redis ML module to do so most efficiently and without using many computing resources. Redis Cell is a module that you can use for for rate limiting, and it's implemented as a language agnostic rate limiter. Rebloom is an efficient way to verify that an entry is not in a set. So it's a probabilistic data structure, once again, probabilistic data structure, and it does not use memory in proportion to the amount of data that's in the set. T-Digest is a rank-based statistics estimator. Top K tracks the top K most frequent elements in a stream, and Count Min Sketch is an approximate frequency counter. In addition to these inline analytics, you also have the capability for operational analytics, such as those that can be implemented with Redis Search, which is an extremely fast text, geospatial, and numeric search engine. Redis Graph, which is useful for graph query processing, and the time series module, particularly useful for time series data. The differentiators for using Redis in real-time analytics is, first of all, of course, you're assured of the performance. It's in memory. You get the characteristic high throughput and low latency of Redis, and it requires the fewest resources to achieve this high performance. The second is a lot of the analytic capabilities, it's almost as if they're aware that memory is an expensive resource. So these capabilities are optimized for maximum memory efficiency so that you don't end up spending a lot on infrastructure. With Redis, you can extend, with Redis on Flash, you can extend your data set to span not just memory, but also Flash SSDs. And particularly in analytics, this is handy because you may have large data sets. With the use of Redis on Flash, you can now get the low latencies of Redis without spending as much money. And lastly, given the types of data structures available, the types of modules available, you can pretty much be assured that Redis wraps around your data while retaining its performance. With the multiple access methods available with Redis, you can also do streaming and messaging scenarios. And this is what makes it so very flexible and versatile to use. Now, in this presentation, we are going to talk about specific examples of how you would use it for inline fraud mitigation for real-time analytics. But of course, there are many companies that use Redis in analytic use cases. Some of these you may have heard from already: Groupon, Udemy, Intuit, and today we'll show you how some of these examples are implemented. With that, I'm going to hand over to Kyle.
Hi, thanks, Lena.
Jump into the examples.
Thanks. Appreciate that. It was a great review of how Redis fits into the whole inline analytics world. Today we're talking about fraud mitigation, which is you know, a great implementation of that. So as we look at this, let's go forward and talk about user geographic checks, right? So in this case, what you're going to do is you're going to check to see if the user is logging in from someplace that seems rational. If someone in the US suddenly logs in from Mongolia, that's going to seem a little bit weird. And you've probably seen this before in, let's say, your Google account or something. You log in from someplace, you're on vacation, you just want to check your email, and it says, this is weird, right? I don't understand this. And so it makes you go through a secondary check. This is the type of stuff we're talking about today. So in this example, I'm going to use something that's a very coarse example for any type of real world situation. I'm just going to look at national boundaries, okay? So how I'm going to determine rationality today is I'm going to do a simple check. So if the person's ever visited the location where they're logging in before, then it's fine. That's rational, right? Now, in the advanced system, and we're going to do both of these, and I'll show you them in just a second, we're doing the bordering regions, right? So I have a simple setup in Redis right now, and this could be from any data source. In this case, I'm just using Redis because this is a Redis example. But I have all the bordering countries. This is something I found online. So you can see like the US borders Mexico and Canada. And if I was to look up other countries, it would have the bordering regions for each one. So I'm going to check and say, okay, I know I'm coming from, let's say, the US. So I can say it's rational that it's in Mexico or Canada. If I was to say Canada, let's say it would border just the US as an example. And so it's just kind of looking at this. Now, this is a very coarse example, as I said before. If you're looking at something a little bit more refined, that makes a lot more sense, right? So the way I'm going to do this is I'm going to use this in how it works in Redis. Let's take a look at this. So every valid location is logged in a Bloom filter. Now, Bloom filters have some interesting properties. They are a probabilistic data structure, as Lena mentioned before. But what they do is they can check for presence very easily. So the most important thing to know is that false positives are possible, but false negatives are not. And the false positives are controllable as well, so you can get a standard error rate. So that means you know for certainty if a user has never been to a location. So we'll take advantage of that. So then the other thing we're going to do in this next demo is an out of hours check. Out of hours basically says, you know, people follow these general patterns in life. Like in your morning, you may check your bank account, you may top up your transit pass, things along those lines. From work, you may look at employee dashboards and partner reports, that sort of thing. And in the evening, you'd look at food delivery, games, and dating apps. So each one of these different services, as an example, would say, okay, it's unusual for you to, for example, check your bank account or top up your transit pass in the evening. That's not your normal pattern, right? So we're going to show a very simple pattern matching. And again, this is a course example in that we're just looking at this from a perspective of, you know, what I can show you in a few minute demo. So how this works in Redis is very similar to how it works in geographic checks. So each time you log in, it's put into a Bloom filter, right? So we're going to check the surrounding times in the Bloom filter. So as an example, if you log in normally at 8 o'clock, we would check 7, and then we'd also check 9. Yet again, you probably want something a little bit more exacting than whole hours. But you can check multiple dimensions. In this, you might want to check, and I'm not going to go over this in the demo because it gets kind of complicated. But you can check time of day, day of week, holidays. So in the previous example, maybe if you always work Monday to Friday, maybe it would be unusual for you to say go in and check some work report on a weekend, and that might be a time to kind of flag that and maybe require some additional verification. And this, for sure it's out of the ordinary because of the properties, the Bloom filter. So let's go ahead and take a look at the demo. I'm going to slide over here. Let's just clear this out. Okay, and then I'm going to first do, you can see this, I'm going to use, each user has their own Bloom filter in this example, and I'm going to use a particular user ID. Let's use 300, which I don't think I've used before. So this is hour 20, so 8 p.m., and they're logging in from the USA. Okay, so I've added that to the Bloom filter, so that was very quick. And then I'm going to do a pattern check, right? So let's use user 300. And of course, this would be implemented in whatever type of API you're using in your system. Maybe you have a REST API that's connecting and getting the information. Well, this can be put in line with it. And then I'm logging in not from the US, but from Canada, and at 8 p.m. So this is going to check first if it's a rational location, and then also if it's a rational hour. And then we'll go through this a little bit more and show how it works in just a second. So in this case, okay, the geo check is true. So if you look at the geo results line here, it says, okay, you've never been to Canada, but you've been to the US, and that makes sense because of the bordering regions. And the out of hours check, OOH, says, okay, yeah, you visited 20 before, hour 20. So that's rational. Well, let's modify this a little bit more, okay? So let's say that I'm gonna visit at 10 a.m. from Canada. So you can see my geo check is still true, and then my out of hours checks is false. That looks like it's not normal behavior. So in this case, and one thing to keep in mind too, all these things kind of are built up into an overall score that would kind of say, okay, yes and no. In this case, my two things are the out of hours and the geo check. So we can see here the out of hours check is false, but the geo check is true. Let's change the location to Armenia. And it's not rational that someone would, for example, who's never been to Armenia suddenly shows up there, right? So this should trigger the geo check will be false. And you can see that's here. Now let's take a look at how this works in code. I'm going to slide over here. Okay, so the probably less interesting one is how I'm doing the visit, right? And like I said, this is just a simple CLI application I created in Node.js, and you can see it's the simplest thing ever. It's 31 lines. So up here is just kind of the boilerplate. I'm requiring some stuff from the command line. I'm loading in some modules. This is all connection information for Redis. No big deal here. I'm using the Redis rebloom module connector library that just enables this in Node.js. It's a very simple library. It's about 10 lines. But it just kind of enables us to use these commands natively. And I'm creating my keys. So in this case, I'm just creating the keys that I'm using to make it a little cleaner. So all that really is doing here is it's creating the client, so it's connecting to Redis, and then after that, it's using the command bf, which is Bloom filter, multiple add, imadd, bf imadd. So that's the command. I'm going to go and say, okay, the key is based on the user ID, so each user has their own. And then the location is logged in, so that's coming directly from the command line arguments. And then I'm also kind of doing a little bit of manipulation here, just for a couple of reasons. But I'm saying, okay, this is the visit during this hour. So that just concatenates these two values together. And then I'm running it, and then I'm just logging that, hey, it's been added, and then I quit. Okay, so that's what happens when I did this top line here. So that's all that was, right? So the checking is a little bit more interesting, and it's a little bit more complicated just because I have to kind of stand up a whole web server. If we take a look at this, some of the same boilerplates up here, certainly. And then if we kind of go down here, I'm doing this login fraud thing. So let's see how this works, and I'll break it down line by line. So first, we're getting the login details hour. We're just changing it into a number because Node.js is JavaScript, and sometimes that's a little bit problematic in JavaScript in general. And then what I'm doing as well, so take that hour as a number, and then I'm just saying, okay, here, make sure we're visiting and that we're dealing with the day boundaries as well. So I'm looking for the hour before, the hour, and the hour after, okay? And then I'm doing an asynchronous check here in a waterfall method, which means that I'm going to do one after another, so the results of one will flow into the results of others. So I'm concatenating all my geochecks together, so I can then just put them right in here. And then I'm using basically the user like I did before, so each user has their own bloom filter. And then I'm putting in these different checks. So there's two different checks here, the geocheck and the hour check. And then I'm just getting the results back out of this, right? So I'm going through, and this will give me for certain if something hasn't happened. So we know that is the property of a bloom filter, and then we're just creating it, and we're doing a sum of these together. So in this case, I'll say, okay, it's returning out ones and zeros. So as an example, I'm checking the bordering countries. So has it been to Canada? Has it been to the US as an example? And then has it been to the hours, the OOH? So 8, 9, and 10 as an example. And then this is just for formatting. This is all that's doing. And then I'm running that and then quitting. So that's how that works. So you can see it's pretty simple. I mean, the whole thing, a lot of this is just kind of manipulating things into hours. I mean, the whole function is 39 lines of code. No big deal. So that's that one. Let's switch back to the presentation here. And we'll look at it, fraud mitigation in kind of a different example. Resource traffic anomalies. This is an important thing to do, and this is something you would put in line. It's a little bit different. It's not based on user fraud, but rather fraud based on access to a particular resource. So if in a denial of service is an example of this, let's say one particular resource on your website, let's say it's a URL, is being hit very frequently by a small number of actors, that would indicate that's unusual traffic. Normally what you'll have is a site that kind of has a balanced view of things, right? So a lot of people are consuming a lot of different pages, right? As a web example. But if you have something that is all of a sudden you have one URI that's being hit by just one user over and over and over again, it can indicate a few different problems. For example, like poorly behaving clients. If you're an API situation, you might have somebody that's written a script that's behaving badly and just an infinite loop. You want to cut that off because that's taking up unusual amounts of traffic. Fraudulent usage, maybe somebody's got a screen scraper or something that you don't really want that's going at a high frequency. DDoS or bots, these are also things that would indicate, you're getting a resource that's being hit by a small number of actors instead of this normal kind of human access mode. So to do this, you have a couple different things. You need to record unique actors, or the people or bots or whatever connecting to it, and then the raw counts for a specific time period. So take a look at it and see that ratio will give you some really valuable things. A high ratio count of unique actors indicates a traffic anomaly. So of counts to unique actors. So let's say that you have, like I said, you're going to push in, let's say that you have 5,000 page views in a certain time period, and then that's by one person. That's going to be weird, right? So how can we do this in Redis, though? Let's take a look at that. We have a key based on a time period. That's a pretty normal thing. So let's say an hour, a minute, whatever. And this is your kind of window. Then you record each visit in two different ways. Use hyperlog log, which is a probabilistic data structure that estimates cardinality. And then it has a small error rate as well. So this is something that can be done very quickly. And it's, you have some error to it, but in this situation, that's okay. Standard error rate is 0.081%, I think. And then you also do another thing. You increment a counter for each visit to each resource. So in that example, if you have, every time somebody, doesn't matter if they're unique, you increment that counter. And that can be really easily done in Redis with the incr command. So let's take a look at this example at the bottom. If you take a look at this, the hyperlog log count, let's say that you have 450 unique users, and we're identifying them however you would identify somebody. Maybe it's a cookie, or maybe it's some sort of analytics ID or something along those lines. Then your raw count, just the number of pages consumed, is 500. So that means that most people are consuming one page at a time. So that's a good result, right? So let's say in the next column, you have 40 hyperlog log users, and then you have 1,000 raw counts, right? So that means that 40 users have consumed 1,000 pages. That's unusual, especially compared to the column to its left. So that would be indication of fraud. Now, the other one is, let's say that you have something where the hyperlog log count is higher than the raw count. In this case, you know something is very wrong because hyperlog log estimates cardinality, and the cardinality is much higher than the raw count. In that case, you have an example of something being tampered with. So you have this little proof that somebody has gotten access to something, and that would be really, really bad. So you have these three conditions that you can have. You have okay, fraud, and tampered with. I would say the far right column would be very, very unusual. Okay, moving on. Let's take a look at this in a demo mode. Let's see here. Okay, so I have this set up. This is a simple little application I'm doing. This is at the top of the screen. There is a set of counters that's going through, and I believe every second generating a little graph that says, okay, what's the unique page views? And if you see up here, the ratio is 0.495. We have 7,000 unique users and 15,000 actual views. So that's pretty much a 50-50 split, pretty close to it. But I'm going to push in some traffic just as an example. Now, if we push in this traffic, right, this should be pretty normalized traffic. It's just going to really change the numbers, but it's not going to change the ratios so much. So I'm pushing in 2,500 unique users, and that's right here. And then I'm pushing in at a volume of 5,000. So it took me 5 seconds to push in all that traffic. And as you can see, the numbers went up as well. But then let's kind of make this plummet, right? So let's show an example of fraud. I'm going to go in and I'm going to say I have one user, and they're going to issue 5,000 page requests as fast as it can. Okay. And this is more limited by my loopback interface than Redis. So it'll take just a few seconds. And as you can see, the bar graph is going down. And we'll see it go down a little bit more. And then you can see the ratio I've set up in my program, anything below 0.4 is considered fraudulent activity. So I'm at 0.3967, and you can see my little bar graph has responded in the same way. As well, that's a pretty extreme example, but let's just say you have 2 users, and so each one's consuming 2,500 apiece for a total of 5,000. As we move through this, we can see how this is working out, and we can see that the numbers are dropping even further. Now, that indicates a fraud, and at this point, you probably would have some sort of mitigation routine where at a 0.33 ratio, but things might recover. So let's take a look at that, and we'll say, okay, now we're going to go back up, and everybody push another 5,000 in, but each of those 5,000 is unique. So then we can see we're in recovery mode, and you can see that the numbers are going up again, and then we're out of that fraudulent activity mode just barely. We're just a little 4.2 over. So in this case, you can really go in and see how that's manipulating it, right? Then I'll show you how this works in Redis, how it looks in a program. So this is the pushing into traffic, right? This is not very interesting. All I'm doing here is just going through and looping through and sending a request over and over and over again. That's not very interesting. The only thing that is interesting in it is that I'm identifying unique users based on a user ID, and that user is, excuse me, just randomly generated. So it's just a user plus a random number. So that's how we're generating that. And then let's take a look at how the actual detection happens. This is where things are more interesting. So as you can see, we've got some of the same boilerplate we had before. I've connected to Redis, and in this case, I'm going through and I'm using the anomaly detection mode. What I'm using here is a middleware pattern. So every request gets this kind of same thing. So it doesn't matter what the request is. It's kind of filtering it all through one method. In this case, it says, okay, if we've got a user ID, we're going to start a multi-transaction. We want to make sure, in this case, Redis is able to handle transactions quite well. So Redis will start a multi-transaction. So these things will be executed atomically. PFAdd is for adding to a Bloom filter. And that means that I'll get my key, which I'm generating up here. It's based on the hour, as an example. And then I'm adding the user ID to that. So by doing that, I can have hyperlog log and get unique users. And then I'm doing the same time, I'm getting a count. So I'm just saying, okay, this is a raw count, and that is also based on the hour as well. So these two things, they're just being done in the middle of the pathway. So you get a question, and then you output a you keep on going, right? So there's no actual things that need to happen that are dependent later on down the line. However, if you were interested in maybe stopping it and having some sort of mitigation, you'd do that in this part right here. So that's fine. But let's take a look at some of how we're going to detect this. And this is the anomaly detection method. So this is the way that we're running the analytics, we're adding the analytics, and this is the detection method. The detection method in this case is being run every 3,000 milliseconds, so every 3 seconds. And this is a case where you might want to run something and say, okay, now I'm reviewing multiple different pathways, and then saying, okay, now I'm detecting something. And what's interesting as well, because you're doing this in Redis, you can have it your Redis server on one, your web server on another, and then you can even have your anomaly detection on another server entirely. So if it is getting hit with these high volumes, it's not in the same process. But for the case of this particular demo, I'm just doing it as simply as I can. So let's look at how it works here. I'm using a batch, which is effectively a pipeline in Redis. I could use a transaction, but a batch is just an easier way because I don't need the guarantees that I would get from a transaction. Up here, I absolutely do need the guarantees because I want to make sure that I'm not getting weird numbers, right? I want to make sure that I'm getting something that's completely atomic. So I'm doing a PF count. Now, hyperlog log has two different operations, and that's, well, three different operations, but two primary operations that it can do. You can add or you can count. So you add something to it or count, which retrieves the cardinality. So I'm getting that right here. And then I'm just getting the simple counter. And so up here, I was incrementing, and then here I'm just getting it. So it'll just retrieve a number. I'm doing some simple math here where I'm taking the results. So when my results key will get both the results from the hyperlog log count and from the get. And then I'm using those there and stored in an array, and I'm just converting them to numbers because yet again, JavaScript will take anything that looks like anything and makes it a string. So I want to make sure I'm having a number so I can do math on it. I'll push this in at this point into my chart, and then this is charting information. I'm using a small charting library called Babar. That does this kind of CLI charting just for visual sake. So I can see here I'm putting this title up here, the anomaly ratio. You see that corresponds to that. And then I have my unique users, which is the result of the PF count, which is this part here. And then over here we have the page views, which is the result of the get, which is getting data from which we've been incrementing. And over here, that's here. And then I'm going through and just creating this little chart, and I'm doing it over and over and over again. And then again, this is just on a simple application. This could be one of many things that you're collecting. So in essence, that's how you can create this really simple protection method. Either inline, you can go in and say, okay, I want to stop this at the time of getting the results back and saying this looks anomalous, or you can kind of run this in a batch every 3 seconds, which I'm doing. This would kind of stop something. You might, for example, every 3 seconds go in and say, okay, have a small check in there and say, okay, this is going to be delayed, or it's going to be return a 500 error or something along those lines. So you can do these kind of really quick checks, either inline or in a small batch every 3 seconds, every second or whatever. 3 seconds is more of a frequency that's reasonable to display during a webinar. So that's the demos. I hope you enjoyed those. I'll switch back over to the screen here. And at that point, I'll wrap it up for questions. We don't really have that many questions today. I'll just go over one that I did receive here. In your example, you use countries. Is there any other method which you would use to evaluate a check of geography? Yeah, so in this case, what I would do, like I said, I use countries because it's simple and it's easy to understand. But one of the great ways of doing that is kind of splitting up the world into hexagonal regions, right? Maybe those regions are a kilometer across, and you would check the 6 surrounding hexagonal regions and seeing, that way you can get a little bit more coarse, right? So the whole United States, that doesn't really help you because it might be you live in Florida and suddenly you log in from Washington State. That's pretty far apart. But if you had some hexagonal regions and you're kind of checking out from, maybe a cluster of regions that are each a kilometer, it would be very fine. Or maybe it's 100 kilometers and you kind of do that kind of all the surrounding ones, and you can do that. That's just a little harder to digest in an example scenario. That's not hard to do. There's many libraries out there that will take, like, for example, a latitude and longitude and convert them into a hexagonal grid, and then you can do those type of checks. Other ways you can do it as well, Redis does have a geospatial engine in it. So you can go in and say, okay, has this been here before? It'd be a little more complicated to implement because you'd also have to kind of convert that into a place to put something for your bloom filter. But that being said, that's all the real questions that we have. So at that point, I just want to say thank you for attending the webinar. And if you have any questions, certainly reach out to us and we'll be glad to answer them. Okay,
hey,
that's it.
Thanks, Kyle and Lena. Hey, on behalf of the entire Redis Labs team, thank you for joining us today. An email with a link to the recording will be sent to you for future viewing and to also share with your workmates. Join us on our next broadcast and go to redislabs.com/webinar and check out what's on tap and register. Until next time, take care.